Hello and welcome to Crossvale's webinar series on the OpenShift CloudBalancer. Crossvale is a premier Red Hat partner with locations in Dallas, Texas and in the UK. My name is Brett Kugler and I am a senior Red Hat consultant at Crossvale. Crossvale provides software and services for the complete Red Hat stack, as well as custom development and products like OpenShift CloudBalancer. When moving into the cloud, it can be challenging to decide what your budget should look like, how you might handle things that occur in the infrastructure while running, how to properly scale up or down, how to suffer through outages or recover from them gracefully, and how to work all of this out, again, with your accountants. We all know that cloud costs can scale very quickly if things aren't handled properly. The adage is true, but the onus is on the consumer to make sure that they are consuming the cloud product properly. In order to reduce your costs and your expenses, you must be aware of how you're utilizing your cloud environments. This means that you cannot treat it like typical data center hardware. It has to be treated as a true OpEx expense. You can no longer keep hardware running in the cloud indefinitely if you're not using those resources. You can't forget to spin down clusters or nodes if they go offline or you're no longer needing that capacity. There's a lot of responsibility on the consumer in this case to manage their costs. In traditional capacity planning, we take a holistic approach to where is my peak load coming from, how much hardware do I need to support that, and then let's add a little bit on top so we can kind of grow into that. And this CapEx model works great when we're deploying hardware into our own data center. It's an investment we spend ahead of time, and then hopefully over time we recoup those costs. As we move into the cloud and away from a CapEx model and into an OpEx model, we find that the same approach just isn't feasible. When you're paying by the hour for compute resources, anything that goes above your peak at any given moment is technically wasted money. But we all have variable workloads, right? So it can be very hard to determine exactly how much capacity we need at any one time. And to have a person sitting there trying to manage this in real time is completely unfeasible. Therefore, with OpenShift CloudBalancer, what we can do is we can monitor the actual usage and consumption of resources in the cloud based on many different patterns, rules, and different intake methods, and decide in real time how much capacity is needed for a given OpenShift cluster. This allows us to model much more closely to our consumption curve and therefore save money. One of the ways that we do this is through leveraging the excess capacity that is available in the different cloud instances. Each of the public cloud providers has a different naming convention for these types of servers. In AWS, they're called spot instances. The idea here is that the cloud services also have excess capacity at times, and they would very much like us to consume that. And so they sell those servers at a cheaper rate for us. However, the problem with that is service is not guaranteed. The any moment in time, we could lose that server because it's now going out to a dedicated instance or higher paying customer, all those sorts of things. In addition, the price is constantly fluctuating. There's a bid price where, if the cost goes above what we're kind of our max peg, what we're willing to pay, then they're going to turn off our machine. And then this happens variably in all of the different regions. So at any given time, any given region might have the cheapest price. And to keep up with this all manually is an impossible task. What OpenShift CloudBalancer does is it solves this problem for you by constantly watching the lowest price, and then if an instance is about to be shut down, it automatically transfers your workloads into another provisioned instance somewhere else. So what that means is you're not having any service interruption while the shift in resources is going on behind the scenes. So how does this look in general? So the idea, again, is twofold when we're saving costs in the cloud. One is we're controlling the number of nodes that we're deploying simply by not pegging at maximum capacity at all times. By scaling up and down nodes as they're needed in real time, we're able to save a considerable amount of money. With the addition of spot instance pricing, that savings escalates even higher because now we're paying commodity prices or cut rate fire sale prices for excess capacity that the cloud providers are wanting us to consume. So no longer are we paying dedicated server rates, we're paying the spot rates. Compound both of those offerings together and you can achieve quite the large amount of savings, as you can see here. Now it's important to point out that for OpenShift, the idea of scaling is already built in. That's at the application level, right? So as long as our nodes, our worker nodes in the cluster have enough capacity, then OpenShift can scale the applications as much as it needs to until we run out of resources. CloudBalancer provides that additional scale by adding more nodes into your cluster. And as we'll see later, those nodes don't have to be in a single cloud provider either. So this means that in conjunction with OpenShift, we can now scale our infrastructure to give additional resources to our applications in real time. So let's take a look at what OpenShift CloudBalancer looks like. Here we see the dashboard of CloudBalancer. And I will just go through and highlight some of the instances of functionality that we have. Over here we have the kind of architectural node build out of the cluster, right? So this looks at all of the nodes that are part of our OpenShift cluster and categorizes them in specific ways. Under the options, we can categorize by role, which is what it's at now, or by cost type. So we have standard versus discounted cost. There are times where we might want to run actual dedicated nodes and spot nodes to kind of have a baseline resources always available, that sort of thing, right? We can also scale by cloud. In this instance, we only have one cloud provider running, so we see a big yellow circle. If we go back to the role, we'll see here that in addition to the master and infra nodes, which are part of any OpenShift cluster, we've broken our other nodes into what we call functional application nodes or fleets. And what this allows us to do is it allows us to tailor an application to fit a specific resource requirement. In a typical OpenShift environment, in addition to the master and infra nodes, we have all of our worker nodes, and our applications get deployed or scheduled out onto those nodes based on certain metrics that we specify within the system. Now, this does not mean that an application will always reside on a certain node. It can, it just all depends on how the rules we set up. Now, what we do for OpenShift CloudBalancer is we take those applications and we define them by an application profile, which is the fleet. And the fleet has a certain instance requirement, number of hardware consumption models tied to it that allow us to define what kind of nodes we need to deploy more of that application. And then we deploy them onto only the nodes that fit those models. So if we flip back to OCB, we see here that we have 10 nodes that are currently running this app. It's a little bit of an unfortunate naming. Let's call this our back-end application, right? We have one node running our online, maybe our web presence, and then we have two nodes running our employee applications, and then one running our invoicing, right? So this gives us a breakdown of the fleets and the nodes being consumed by those fleets, right? And if we look down here in the big yellow numbers on each of our fleet instances, we can kind of see how those would map up together, right? So these two, the 6 and the 4 here, comprise our 10 application nodes, right? The reason they're split out is because we wanted to have them run in different environments, right? We might have a blue-green or something like that. So you can even launch applications in different fleets, even though they're the same application. In this graph, we get to see what our real-time cost savings are. We can obviously look at individual items, or we can look at group items. And it's just a nice little reminder that at any given moment, we are actually saving a considerable amount of money because we're using these spot instances. The third widget here shows us our total hardware consumption for the cluster. You see we're using a fair amount of memory, not so much CPU. If we dial down there, we can see that the app clusters, as expected, would be consuming the most amount of memory. This is simply because we're running the most nodes, and it's the most application or workload intensive application that we have. Lastly, on the right here, we have a nice little graph showing you savings over time. So monthly savings and a percentage. Again, this is based off of the dedicated rate versus the spot instance rate. So if we come down here and we look at a fleet, there's some interesting things to note about this. But I'm going to click on the little information button here and show you around kind of what the metadata looks like for a fleet application. So we get to see what clouds it's running in. I'll talk more about the mode here in a second. We can see where it's running, what availability zone is available to it, the instance type, and then we can look at the costs, right? So we're currently paying about 6 cents an hour. The estimated cost for a dedicated node would be about 30 cents an hour. So that's a considerable savings. This is our bid price. This is our maximum comfortable level. Again, we can define that to make sure that our workloads stay longer without having to be moved, or whatever it is that we're comfortable with. Here we get kind of a breakdown of what that node looks like. Again, these are servers, in this case in AWS. And so we see the total number of memory, what we have free, and the type of image it is, et cetera, et cetera. If we wanted an additional node for this, we simply hit the up arrow, and then we can change the capacity that we want. If I go ahead and set this capacity to 2, we'll see that fleet scaling has begun. We can scale back down, and we can change the mode. and I mentioned that we would talk about the mode in a minute, and that's still coming up. And then obviously we can delete the fleet if we so choose. So I just scaled up this instance. You may have noticed that it was on autopilot, and now it is switched to manual. This is because I went in and I adjusted the number of nodes for this fleet manually. So it automatically switched from autopilot to manual. If I come down to this particular fleet, which is set at manual and it's currently not running any nodes, and I turn autopilot on, then it's going to start deploying nodes for this fleet to match these settings. Well, what are these settings? So one of the really cool parts of OCB is you don't just scale these things up and down, your nodes up and down randomly, right? You can deploy in multiple clouds. We saw that with us just deploying on AWS, and we'll talk more about that in a second. But what we've done is we've built a connection into any rules engine that has an API layer associated with it. In this case, we're using Red Hat's Decision Manager. Drools works just as well. Some of the metrics that we can monitor to decide on whether we scale or not that come out of the box are things like just a time schedule, calendar, date, hours, whatever, memory consumption, CPU consumption, that sort of thing. We can trigger scale up, scale down based on those values straight out of the box. We can also expand our business logic to scale based on other extemporaneous factors, things like the weather, our stock price, whether we're about to launch a new product, or our API is seeing a spike in traffic, or we're releasing a new feature for our application. We know there's going to be an uptick in traffic. So all of these things can be built into our rules managers in order to drive when we scale up and scale down the cluster. So if we'll take a brief look here at Decision Manager, just so I can kind of show you what this looks like. So here is our one of our decision trees, right? Basically, what we have here is we have all of our different fleets that are shown by their ID. If we switch back over here into CloudBalancer, we see the beginning and the end of those fleets. You'll see over here that there's actually some activity as AWS is now provisioning the nodes that we requested. We see this one's adding one. Remember, I clicked the up arrow once, so it's adding one node. This one's actually going after the autopilot scheduling. So whatever we have set in our rule for how many nodes it should be running, that's what it's increasing it to. So you see here it's adding 2 nodes. So if I look at this SFR5EA and I go back to Decision Manager, and I find that particular line item, which happens to be this one right here, and our time right now is between noon and midnight, we see that the target capacity for this particular fleet should be 2 nodes, right? And indeed, that's what it's spinning up here on autopilot. As the system continues to build, we get continuous updates and events telling us what's going on. Here we see how when I switched that particular item to autopilot, we see that it's constantly checking the business rules. So it's talking to the rules manager, the decision manager, constantly to make sure that everything's in sync and it's following and rules haven't changed and that sort of thing, right? And then it's scaling up as we go, right? So it'll continue to do that until it's quiesced and all of the fleets have met their capacities. You'll see our pie chart up here has changed a little bit. We now have 3 nodes that are marked as unavailable. Those happen to be these 3 new nodes that are currently coming up. As soon as they come up, we see that they're part of the online fleet. So this little blue pie widget here will expand up to 4 nodes. We've got 1 node running right now. There will be 2 more that become available. 3 more that become available, sorry. So OCB itself runs in your OpenShift cluster. So it gets deployed just like any other pod would, and manages all of your workloads and all of the cluster scaling and all that from within your OpenShift cluster. Crossvale would like to invite you, if this has caught your interest, to give us a test drive. We're offering for the month of October this special where you can consume OCB, put it in your OpenShift cluster. There are no currently any node limitations, no compute or memory limitations to that. There's really no fine print at all. It's for 2 months, 10K. Please visit us at the link provided if you're interested. And that's our presentation today. I would like to thank everybody for joining, and we'll talk to you again soon.